We're going to take one final look here at maintaining blood calcium, and we're going to go into more detail about PTH and its synergistic partner, calcitriol. We're going to begin this story with vitamin D. This molecule right here is vitamin D. And there are two ways you can get vitamin D. We already talked about this in Chapter 6. Remember that sunlight stimulates your skin to convert cholesterol to vitamin D. So if you notice here, there's two arrows here pointing to vitamin D. So one way that you can get vitamin D is from your skin. Your skin will convert cholesterol when you are in the sun. So UV light stimulates your skin to convert cholesterol. So there's the cholesterol that your skin's going to convert into vitamin D. The other way to get it is from your diet. So they have a picture here of a glass of milk as representative, but there are a lot of different foods that contain vitamin D. Either way, you end up with vitamin D in your blood. So if you're sitting out in the sun and your skin's making it, or if you're drinking a glass of milk or eating some other food with vitamin D, either way, you now have vitamin D in your blood. Your blood is flowing through your body and it's going to go through all your organs. As this vitamin D flows through your liver converts it to calcidiol. So this molecule is calcidiol. It used to be vitamin D. So as the vitamin D flows through your liver converts vitamin D into calcidiol. Then your blood's still flowing through your body. So now you have calcidiol in your blood, and your blood is going to flow through your kidneys. So now we have calcidiol in your kidney. Now we're going to pause there and we're going to come over to the other side of our story. Remember here, these little dots inside the thyroid are your parathyroid glands. And they monitor your blood calcium. And when blood calcium is low, they secrete PTH. So from these parathyroid glands, we're going to get PTH. The lower your blood calcium, the more PTH. The higher your blood calcium, the less PTH. So low blood calcium corresponds to more PTH. The lower your blood calcium is, the more PTH you have. Now, before I mentioned PTH has a synergistic partner, it's like Batman and Robin. PTH has to go get its synergistic partner. So PTH is going to go to the kidney. Now, we left off with calcidiol sitting there in your kidney. PTH tells your kidney to convert calcidiol to calcitriol. So over here we can put your kidney converts calcidiol to calcitriol when it is stimulated by PTH. So that's the important part here. When stimulated, we'll put by PTH. So the idea here, in order to get calcitriol, you first have to have PTH. If you don't have PTH, you'll have vitamin D, you'll have calcidiol, and that's it. You just stop there. To do that last step and get calcitriol, you have to have PTH. And the more PTH you have, the more calcidiol your kidney will convert to calcitriol. So more PTH also equals more calcitriol. So now you have PTH and calcitriol together in your blood. So this molecule here is calcitriol. So it used to be calcidiol. It gets converted to calcitriol by the kidney when the kidney is stimulated to do so by PTH. So just a review of what we have so far. You get vitamin D either by in your food or sitting in the sun. Your liver converts that to calcidiol. Then your parathyroid gland monitors your blood calcium level. When blood calcium is low, it secretes PTH. PTH tells your kidney to take that calcidiol, convert it to calcitriol. Now you have PTH and calcitriol in your blood. And the lower your blood calcium, the more PTH and calcitriol you have. So these two hormones are synergistic partners. So remember, that's like Batman and Robin. They're going to work together. And if we think about their job, remember, homeostasis is your overriding goal. Well, if their problem is that your blood calcium is low, they are going to work together to raise your blood calcium to bring you back up to homeostasis. So the bottom part here shows us the effectors. This box, and this is something this textbook does consistently, so get used to seeing a blue box at the bottom. This is our effectors. So think back to chapter 1. Remember when you first learned about homeostasis, you have a stimulus. In this case, the stimulus is the low blood calcium. You have the gland that's going to sense that. Your parathyroid gland senses it. It secretes a hormone, PTH, which gets its partner, calcitriol. Then you have the effectors, which are going to fix the problem. Your problem is low blood calcium. So here we have 3 effectors. The first one here represents osteoclast. So there's a picture of a bone, and this represents the osteoclast in your bone. So both PTH and calcitriol are going to work together to stimulate the osteoclast in your bone. You're going to make the osteoclast in your bone work more so that they will dissolve more bone, and they will put that calcium into your blood. So they will move calcium from the bone to the blood. And the effect of that is to increase your blood calcium. Then our next effector is the kidney. This one is also going to be PTH and calcitriol working together. So your kidney filters your blood. And all the gunk that it cleans out of your blood becomes urine. Urine is stuff you want to get rid of. So think about like you're cleaning out your closet and you're deciding what you want to keep and what you want to give to Goodwill. You're going through, you've got a t-shirt, and you're like, I don't know, am I going to wear this t-shirt? Should I keep it or should I give it to Goodwill? You have to decide. That's what your kidneys do. They're cleaning out your blood. And every molecule that's in your blood, your kidney has to decide, should I keep this molecule? Do we need it? Or should I put it in the urine and get rid of it? Well, you have hormones that help your kidney make that decision, right? So imagine your friend is there and your friend's saying, oh yeah, that's a really cool t-shirt. You should keep it. That's what PTH and calcitriol do. They tell your kidney to keep the calcium in the blood. They say, oh, kidney, we definitely want that calcium. Don't put it in the urine. Keep it in the blood. So as long as you have PTH and calcitriol, you're not going to lose calcium in your urine. You're going to keep it in your blood. The last one here is calcitriol alone. And this is going to come up again later. It's going to be important. Calcitriol alone stimulates your small intestine. Your small intestine is what absorbs nutrients into your blood. So you eat food, and your small intestine is what transfers the nutrients into your blood. Anything your small intestine does not put into your blood becomes feces. So let's say you eat some food that's high in calcium. That food is now in your intestine, and it's broken down into all its component nutrients. And your intestine has to decide which nutrients do I want to put in the blood. So which nutrients does the body need that I should put into the blood? And which nutrients should I just let become part of the feces? I don't want those, right? It's like going shopping. You're walking through Walmart and there's all this stuff there. You have to decide what you're going to put in your cart and buy and take home, and what you're just going to pass up and leave there in the store. That's what your intestines are doing. You eat food, you put all these nutrients in your intestines, and they have to pick through and decide what goes in the blood, what becomes feces. Well, calcitriol tells your small intestine to put the calcium in the blood. Without calcitriol, the calcium you eat would just go into the feces. You wouldn't actually get it into your blood. It would be a waste. So that's how you manage your blood calcium. And one of the important parts here, that end part with the calcitriol in the small intestine. Let's just suppose that you eat a high calcium diet. So you are putting lots of calcium into your small intestine, but you lack vitamin D. Okay, so you never go out in the sun, you don't eat foods that have vitamin D, your body's lacking vitamin D. What do you think is going to happen to all that calcium that you eat? Well, in this case, if you lack vitamin D, if there is no vitamin D, then you get no calcidiol, which then means no calcitriol. Okay, if we look back up here, calcitriol used to be calcidiol, and calcidiol used to be vitamin D. So if you take out the first step, you lose steps 2 and 3. Well, if there's no calcitriol, then there is nothing to tell your intestine to put calcium in the blood. So you would eat your high calcium food, and this food would go into your intestine, and it would be broken down into all its component nutrients, and you'd have a bunch of calcium sitting there, and your intestine is picking through, deciding what to put into the blood, and there's nothing there to tell it to put the calcium in the blood. So it doesn't. It's like walking through the store, and you forgot to put calcium on the shopping list, so you don't put it in your cart, you don't take it home. All that calcium you ate just gets lost in the feces. You would then become deficient in calcium also. So if you pay attention, calcium tablets, like if you go to the vitamin aisle at the store and you look at the calcium tablets, they also have vitamin D with them. If you just take the calcium by itself and you don't have any vitamin D, you won't absorb the calcium. You'll just have a bunch of calcium in your feces. The only way to get calcium into your blood is to also have vitamin D, because the vitamin D gets converted to calcidiol, which gets converted to calcitriol, which then stimulates your intestine to absorb that calcium. And this is assuming you're taking your calcium tablet every day. When you say you start taking a calcium tablet, with that first calcium tablet you take, you're going to poop out the calcium because you have to get that D into your system so that it has time to go through those conversions and become calcitriol. Then tomorrow, when you take your second calcium tablet, now you'll have the calcitriol and you'll be able to absorb the calcium. But that's the link between calcium and vitamin D.